This is MAT 2020 Lecture 39. This will be the only lecture of this week, which is Thanksgiving week, and we will be covering the material in section 11.8 today, which is about power series. So what's a power series? A power series has the form, let's say C0 plus C1 times X plus C2 times X squared plus C3 times X cubed, etc. In other words, it's of the form sigma n goes from 0 to infinity of Cn x to the power of n. So you can think of this as like an infinite degree polynomial, because if some of these constants, C's are constants, so Ck is a constant. For all k, it's a coefficient in front of x to the k. And if these C's are eventually 0 down the line, then what you get is an actual polynomial. But if not, it's sort of like an infinite degree polynomial, and that's what a power series is supposed to be. So an example to have in mind is something we've already had. So let's consider 1 plus x squared. This is the case all the coefficients are 1. So this is summation x to the n. Now you can think of this as a geometric series, and with initial term 1 and common ratio x. And then this will be equal to 1 over 1 minus x if absolute value of x is strictly less than 1. We saw that already back when we talked about geometric series, and it diverges otherwise. Okay, so that's the basic question we always ask about a power series. For which x, when you plug in the number x, does it diverge? But before we move on to studying questions like this, I want to talk about a slight generalization of what we were talking about power series. This is a so-called power series centered at x equals a. What does this mean? Well, this will be a series of the following form: C0 plus C1 times x minus a plus C2 times x minus a quantity squared, etc. In other words, it's equal to summation C n x minus a to the nth power, n goes from 0 to infinity. Okay, so that's the notion of a power series centered at a. All right, so let's do some examples now. I'm mostly going to do, I'm going to do examples of a very general kind today. So here's an example: summation n goes from 0 to infinity, n factorial x to the n. So for which x does it converge? So for which x does this series converge? Which real numbers x? Well, what we always do is we start off with the ratio test with these types of questions, or maybe the root test in some cases. But the ratio test is the main tool. Okay, and how it works is, well, what is the nth term, the n plus first term? Well, that would be n plus 1 factorial x to the n plus 1. And what is the nth term? That would be n factorial x to the n. We take the quotient, and then we let n go to infinity. Now, this expression, of course, is the same as n plus 1 factorial over n factorial is n plus 1 times x, because x to the n plus 1 over x to the n is x. And you can think of this as n plus 1, since n is always non-negative. times the absolute value of x. Now, what happens when n goes to infinity? So as n goes to infinity, two things can happen. You get 0 if x equals 0, right? And if x is not 0, then n plus 1 times x, since x is just a fixed number, is going to go off to infinity. So the series diverges unless x equals 0 in this case. So that's the example. Let's try another example to see that different phenomena can occur. So let's consider the sum n goes from say 1 to infinity. We have to start with 1, you'll see in a moment. X minus 1 to the n over n. So if we do the ratio test here, we would get, so the ratio test we would take x minus 1 to the n plus 1 over n plus 1 times the reciprocal of a sub n, which is n over x minus 1 to the n. We would then take the absolute value and then do some rewriting, and this would be n over n plus 1 times x minus 1, which we can factor out the n over n plus 1, and then you get an absolute value of x minus 1 inside the absolute value. Now, what's happening when n goes to infinity? When n goes to infinity, this term circled in yellow tends to 1. And so, and the term in the absolute value doesn't change. So this is going to tend, when n goes to infinity, to the value of x minus 1. So what does that tell us? It says that if absolute value of x minus 1 is strictly less than 1, the series converges. And if strict absolute value of x minus 1 is strictly greater than 1, the series diverges. So now writing x minus 1 is less than 1 is the same thing as x is between 0 and 2. And so it converges when x is between 0 and 2, and if x is outside that interval and not including the endpoints, it diverges. So we have to check endpoints. I'm going to check the endpoints here, check the endpoints, because that's the only remaining cases of the interval from 0 to 2. So if x equals, say 2, what happens to the series? You get summation 1 over n, which diverges. It's the harmonic series. And if x equals 0, you're going to get summation minus 1 to the n over n, which is the alternating harmonic, which converges. So the answer to the question, which I'll give in green, is that the series converges for all x in the half open interval of 0, 2, and diverges otherwise. Okay, these two examples I just gave actually lead to the following result that which we can actually, it works the same way, you'll see. And it goes like this. Here's the fact. So given a power series, summation c sub n x minus a to the n centered at x equals a, and goes from 0 to infinity, there are exactly 3 possibilities. There are 3 possible. Okay, so here are the 3 possibilities. Possibility 1 is that the series converges only at the value of x equals a. It certainly converges when x equals a, because if you stick in x equals a, you're going to get the series of zeros. Second possibility, the series always converges for all x in the real numbers. Okay, so that's the second case. In the third case, which is sort of the most interesting case, there is a number, a real number, r greater than 0, positive real number, such that the series converges on the interval from a minus r to a plus r. So here's the picture that we have. We have the number a, and then here's a plus r here, and then we have a minus r over here. So the distance between the endpoints of this interval, between the green points to a is directly in the center, so it's symmetrical. And now it could, and this r, this number r, is called the radius of convergence. On the endpoints of this interval, on the endpoints of this interval, a minus r to a plus r, anything can happen. The series can either converge or diverge. In other words, the series can converge on maybe a minus r, half open a plus r, or it can converge on the half open interval a minus r, closed interval a plus r, or it can converge on the closed interval a minus r, a plus r, or maybe it can, or on just the open interval a minus r, a plus r. So there are 4 cases really embedded in here. Okay, so you have to always check the endpoints. So to check for the radius of convergence, we just have to use usually the ratio test. Okay. So, okay, so we have actually talked about cases where case 1 occurs, the series convergence always only at x equals a. We've also talked about an example of case 3. The next example I'm going to give you is an example of case 2 where the series always converges. Here's an example. Summation x to the nth power over n factorial, n goes from 0 to infinity. So we're going to use the ratio test as usual. We'll get n x to the n plus 1 over n plus 1 factorial times the reciprocal of x to the n over n factorial, which is n factorial over x to the n. We have to take the absolute value and we rewrite it, and we're going to get, I'm going to just simplify directly. You get 1 over n plus 1 times absolute value of x. Now what happens when n goes to infinity is this term goes off to 0, and so this always tends to 0 as n goes to infinity. So therefore, the series converges for all x in R. Okay, so that's cool. Okay, so what I like to do is another example. So this example is summation n factorial times 2x minus 1 to the n. N goes from 0 to infinity. Now this doesn't look like the usual way of writing a power series centered at a number a, because we have this 2x minus 1 here, but you can actually rewrite it as such. It's the same as the sum n goes from 0 to infinity. We can bring the 2 to the n out, and so you're going to get n factorial 2 to the n times x minus 1/2 to the n. So this series is actually centered at x equals 1/2. Okay, so this is a power series. That's what I've just showed you. So now we're going to use the ratio test. So we're going to get n plus 1 factorial 2x minus 1 to the n plus first power over n factorial times 2x minus 1 to the n. We have to take the absolute value, and we're left with what? Well, there's going to be an n plus 1 over n factorial. We can bring it through the absolute value to get an n plus 1. And then what's left over is 2 absolute value of 2x minus 1. And then two things can happen here. What are the two things? If 2x minus 1 is equal to 0, in other words, x equals 1/2, the series converges. And the series converges. And if x is not equal to 1/2, the series will diverge. So this was this was like a case 1 situation. Okay. Okay, so I'm going to give you one final example in this lecture, which is the series 1 plus 2x plus x squared plus 2x cubed plus x to the 4th plus 2x to the 5th, and so on. So the coefficients alternate. So C even, so C2n is equal to 1, and C 2n plus 1 is equal to 2. So the odd power terms have coefficient 2. So this is, in other words, the same thing as summation, Cn x to the n, where Cn is given by the values I'm circling now. Now, there are a couple of ways to do this problem. Probably the most elegant way, you can do the ratio test, but you have to do some work with that. The most elegant way to deal with this problem is to note that this is 1 plus 2x plus 1 plus 2x times times what? So times x plus 1 plus 2x times x squared plus 1 plus 2x times x cubed, etc. In other words, it's 1 plus 2x times 1 plus x squared, etc. Now we know that this power series is geometric and will converge to 1 over 1 minus x if the absolute value of x is less than 1. And otherwise it will diverge. So the radius of convergence is 1, and the expression that you get is going to be equal to 1 plus 2x over 1 minus x. You multiply the numbers together if absolute value of x is less than 1 and it diverges otherwise. So that's all for today. That's all for power series for the moment.